Dear students, in today's class I am going to start a new chapter, electric potential and capacitance. So, let us start understanding what exactly electric potential is all about, and this definition has appeared twice in the examination. Define electric potential. To understand that, let us consider a charge plus Q, which I call it as a source of charge, a source of electric field. It produces electric field and is extended till infinity. And from this infinity, if I take a test charge Q naught, so this is the source of charge which produces the electric field, this is the test charge which is used to measure the existence of the electric field. It is also used to measure the electric potential. So, this is a positive charge and this is also a positive charge, and then if I have to move this positive charge from infinity to a particular point P, I have to do the work because these two charges are like charges, they repel each other. So, what is the work done in moving this charge from infinity to a particular point P? Work done in moving from infinity to a particular point P is given by the charge moved, which is a Q naught, into a quantity which we call it as electric potential, denoted by V. So, where V is the electric potential at this point. So, therefore, how to define electric potential, how to measure the electric potential? V is equal to W divided by Q naught. So, from this it is very clear. So, this is the one of the formula which you have to remember, important. So, from this V is equal to W, V is equal to W if Q naught is plus 1 coulomb, which we call unit positive charge. Unit means one, unity, and then it is a positive charge. Therefore, the definition of the electric potential is, electric potential at a point is defined as the work done in moving unit positive charge from infinity to a particular point P or to that point. Okay. So, here we can define electric potential. So, electric potential at a point is defined as the work done in moving unit positive charge from infinity to that point against the electric field. So, this is the definition of electric potential. So, let me repeat the definition. Electric potential at a point is defined as the work done in moving unit positive charge from infinity to that point against the electric field. What is its SI unit? The SI unit is W is in joule, charge is in coulomb. So, joule per coulomb is called as volt. So, therefore, the SI unit of charge is volt, denoted by capital letter V. Okay. So, that is the SI unit of electric potential. Do remember, important. And it is a scalar quantity because work is a scalar, charge is a scalar. Therefore, electric potential is a scalar quantity. Electric field is a vector quantity, whereas electric potential is a scalar quantity. Potential difference. So, this is the term which we highly use. Potential, electric potential is measured at a point, at one point, whereas potential difference is always measured between 2 points. Therefore, how to write this particular equation? W, work done in moving a charge from one point to another point, WAB, is equal to the charge moved into V I will write VAB is equal to VB minus VA. So, what is this equation for? Work done in moving the charge Q0 from A to B, from A to B, from one point to another point. Let me consider 2 points here, A and B. If I move this charge Q0 from one point to another point, then what is the work done? So, this is the equation to find the work done when the charge is moved from infinity to a particular point, right? So, this is the expression for work done in moving the charge from one point to another point, from A to B, is given by the charge moved into VB minus VA. By the way, what is VB? What is VA? V is the electric potential at A, whereas VB is electric potential at B. So, that VB minus VA gives potential difference between the 2 points. VB minus VA gives the potential difference between the 2 points. And this potential difference is that decides the amount of the work done. If the potential difference is more, the work done is more. So, how do you measure the work done in moving the charge from A to B? It is Q0 into VB minus VA. So, how about work done in moving the charge from B to A? Then it is the charge moved into, you have to always write the final. See, this is the initial point, this is the final point. So, you have to write final potential first minus the initial potential. Okay. So, potential at A point, whereas the potential difference between 2 points. So, that is how we measure. And this is how the various devices are indicated with the potential differences. So, for example, if I buy a bulb having rating 10 watt and then 10 watt 220 volt. So, this 220 volt is the potential difference that I need to apply across the bulb so that it consumes an electric power of 10 watts. So, therefore, this 220 volt indicates the potential difference. Even in various cell battery, you get to see the potential difference written, 1.5 volt, 10 volt battery, 8 volt battery. So, therefore, that 8 volt that is written is nothing but the potential difference between the two ends of the battery. If the battery has a more potential difference, it does more work, less potential difference, less work, and if there is no potential difference, and if that battery is, if it is not capable of generating the potential difference, then the work done is 0, as the potential difference is 0. So, hope you have understood these important terms. One is electric potential, SI unit is volt, it is a scalar quantity, and the potential difference is always measured between 2 points, whereas electric potential is measured at single point.